We'll wait for a couple of more minutes and then we'll get started here. Okay, Provectus is a top tier preferred AWS partner. We specialize in AI and ML solutions, and that's our core area of expertise. And we are headquartered in Palo Alto, Bay Area, in Silicon Valley. We have offices across North America and Europe. We have 450 engineers and growing. And clients, we have a very, very nice mix of clients. We have fast-growing startups and large enterprises, which help us to be on the cutting edge while working with the startups and then implementing enterprise solutions with large enterprises and take that to the enterprises. Just to kick it off, as a part of this webinar, we'll make it interactive. Our goal is to provide, tremendous value to you in next 1 hour, and at the same time, get enough information back so that we can come back with some interesting offerings to you guys. So it's a poll time. There should be a poll tab in your control panel. So the question that we're asking is, what is the level of ML adoption in your company? And there are 4 possible answers. If you guys could take a minute and answer those. So the first one is exploring from bottom up, looking to prove first use case. And second one is having a strategy and buy-in, looking for technology to execute. Third one is have a couple of models in production and looking for scale. And the fourth one is have adopted ML application across different product lines, and now you want to further energize it and expand it. Okay. Awesome. Thank you for sharing that information with us. And at this point in time, I'm gonna go ahead and introduce my other esteemed co-panels, presenters over here, and our CTO, Provectus Chief Technical Officer, Stepan, will take the webinar from here onwards. And I will be, towards the end of the webinar, I'll come back and ask a few questions. And
all right. Thanks, Preetpal. Yeah, thanks for the intro. Let's jump in. Thanks for your answers for the poll. It's really good to know who we talk to. Yeah, so it's those are poll results. I'm sure it's why it's popping up this way. Anyway, the webinar's title is SageMaker and Beyond, and the key word here is beyond, and that kind of there are some expectations that we have from you guys. We expect you to be familiar with machine learning in general. We're not going to talk about machine learning 101, and we're not going to talk about SageMaker one-on-one fundamentals like notebooks, training, and hosting. We will be using some AWS ecosystem services as we speak. So I hope you are pretty fluent in this terms like DynamoDB, Glue, S3, and other fundamental things in AWS ecosystem. Bear with us. Hopefully, it will go as smooth as possible. So the outcomes, why we expect you to be here. First of all, we expect you to take home a deep understanding of AWS SageMaker capabilities, limitations, and opportunities. Also, we will be talking about the best practices for using AWS SageMaker with open source tools for better experience and productivity. We hope to give you a holistic understanding of integrations of machine learning processing into the rest of the AWS ecosystem. You know that the services that lays formally are outside of the SageMaker family, but are essential part of the end-to-end AI solutions. And the cherry on the cake of today's webinar is a special offering by Provectus and AWS on a machine learning infrastructure acceleration program. Bear with us till the end. We're going to present some very interesting offering. At this slide, I would like to introduce the AWS Rockstar as solution architect, Chris Burns, who is going to kick it off from the AWS side and walk you through this AI stack on AWS.
Thank you, Stepan. I don't know about that Rockstar part, but it sounds pretty good. Thank you, everyone, for attending today. I know how webinars can eat up a day, so I appreciate your time today. What I want to do, as Stepan, as he alluded to, is I want to walk through this stack real quick. We call this a stack because we sort of formulated these services in layers. Now, the top layer here is the Provectus value add. So I'm gonna ignore that layer for just a moment. I'm gonna dig into these three dark blue layers. I'm not gonna go over these services one by one. If you were to come back and check this slide again tomorrow, chances are you might see something new on there. So it's not expected of you or even myself to have every one of these memorized to the point where you can exhibit expertise on them. The stack is really meant to demonstrate the depth and breadth of services, because the key point you're going to hear from Stepan and Provectus today is that machine learning models are only part of a solution. When you get an inference back from a machine learning model, that's not judgment, that's an inference. You still have to make judgment, you still have to take action on that. So you still have to bake these ML models into overall solutions. And these solutions still have to be scalable. They still have to fit into CI/CD pipelines. They still have to be fault tolerant. They still have to be secure. So all of the traditional cloud infrastructure or cloud architecture paradigms that we've come to know the last 5 years are still just as important today as they were before machine learning became so mainstream. And that's where I believe AWS really plays a key role in this scenario. We provide not only this ML Stack solution, these offerings for you, but our traditional portfolio of services, over 175 services now. As Stepan mentioned, DynamoDB, S3, VPCs, these are all the new substrate that you can't build without. And today we're going to hear primarily about SageMaker. So I got off on a little bit of a tangent there, but the topmost dark blue layer, the AWS AI services, these are API-based services that allow you to incorporate AI into your applications very seamlessly. So no machine learning expertise required. Simple APIs. You pass in data via API, you get back results via API. Middle tier is where we're going to focus today. That's SageMaker, and SageMaker is a bridge. It's a bridge in more ways than one. It's a bridge between data scientists and developers. It's a bridge between this top layer, AI services, and the bottom layer, the ML frameworks and infrastructure. This is where we have our deep learning AMIs. We have GPU fleets for HPC or for large clustered or distributed training environments. Those are for the folks that understand the ML and have to take a framework like TensorFlow or MXNet and really bend it to their will. So SageMaker is that bridge in between. SageMaker has got a user-friendly interface. It allows almost anybody to come in there into a Jupyter Notebook and to start researching and exploring. We just launched SageMaker Studio at the latest reInvent, which it's the latest incarnation, if you will, of SageMaker. We added an IDE, lots of features that we're going to dig into in a little bit. But I don't want to steal Stepan's thunder. Really, I'm just here to talk about this slide and also to talk a little bit about Provectus. Provectus is a great partner. I've been working with Provectus now for 2.5+ years. And they're a great partner, not just because I'm on their webinar. It seems like a little self-serving. I chose to be on this webinar because I like Provectus. I like Provectus because they understand that you can't just train a model in a notebook and pass it off to a customer. They understand how to solve problems by building solutions that incorporate machine learning. They're part of our ML competency program. That's a higher level tier for partners who have exhibited production ready use cases, and I've put them through the grinder personally on these use cases, challenged them on architecture, challenged them on decisions they made, and they came out, with flying colors. And I'm real happy to support them here today. And if there's any questions that are AWS specific, happy to answer those questions. Otherwise, I'm going to hand it over to you, Stefan, and let you get to the good stuff.
Thanks, Chris. Let's jump in further into some details. As a follow-up on the previous slide, this is a screenshot from the SageMaker landing page, the same version, but a little bit simplified. And again, I expect you to have a familiarity with basic SageMaker services like notebooks, training jobs, and hosting. I'm not going to cover this today. Instead of that, we're going to cover something new and something really exciting, like a SageMaker experiment, SageMaker debugger, and SageMaker model monitor. Those are three main services that we're gonna talk today from the SageMaker ecosystem, and we'll be also talking about some components that you can build yourself using existing AWS services like Glue, EMR, and others that will form the essential components like data sampling, the way you transition from the Infinity data lake to the Finity data sets, the data sets versioning and feature store that are fundamental parts of the building robust machine learning infrastructure. And we'll be briefly talking about the end-to-end machine learning workflow orchestrator, such as Kubeflow. That's kind of a brief agenda illustrated on this slide. So a quick like a level setup for machine learning infrastructure. Are we when we are talking about new tools, new abstractions for machine learning, are we serving our engineering ego, or this is something this is a must-have, a requirement from the business? I would briefly talk through the real-world use case when all these components that debugger, monitoring, data lineage are must-have requirements from the business and not from the engineers. In this case, it's a healthcare industry, very conservative and very constrained and very regulated industry. And like I would like to briefly go through this use case of FDA compliant disease screening. The use case itself is really social impactful. We prevent vision impairment for newborn babies, and the technical machine learning part of this project is like image classification and a classification of the retina images or of a newborn born babies to prevent a vision impairment. That's kind of as a machine learning part of the project, but the most crucial part of the project is our FDA guidelines that really offer you best practices for machine learning, end-to-end machine learning solutions. And if you will take a look at those guidelines, there is nothing special here. And as any stakeholder of any machine learning project, I would require my infrastructure to follow these guidelines and best practices. Even as every single machine learning engineer, I will require my infrastructure to have automated model validation, to have a culture of quality and organizational and excellence, to have automated retraining, to have a production monitoring. So all these things are not an extra things. There are essential things to be built for any serious machine learning project in any industry, healthcare, retail, manufacturing, others. Yeah. So starting with data lake. it's an axiom that any enterprise machine learning starts with data. I believe you're kind of 100% agree with that. And I've been hearing a lot of new buzzwords and terms regarding the machine learning reproducibility, models versioning, machine learning bias detection and fairness, machine learning auditability and other similar things. My answer to all of that it all starts with data. We need to produce reliable data sets. We need to version the data set before starting versioning the models, because the models are being built from the data. We are detecting a bias and fairness on a data set, not on a machine learning model, and etc. Same for governance, same for monitoring. That's why. So I would kind of make a step back and outline the data infrastructure that we recommend building to power machine learning use cases. Data lake, the term that you are all familiar with, usually built with S3, and in AWS ecosystem usually built with S3 and Glue Catalog. Infinity dataset powered by data pipelines with decoupled compute and storage. All clear, all straightforward. Then we recommend adding a machine learning awareness into a data lake. The awareness is being brought by the metadata. And the way you manage the metadata, the machine learning specific metadata, like the prediction and confidence for if a particular records are being enriched by machine learning models along the pipeline, an annotation metadata, a column specific metadata such as upstream machine learning models that columns are being used by, and a higher level operations like a sample from the Infinity the data lake to some affinity data set. So it's all the characteristics of the machine learning aware data lake. As I mentioned, it could be easily built with the existing tools, EMR, Spark on EMR, Athena, S3, and a bunch of best practices surrounding this. For instance, as a sampling query, we can implement the pure functional query that produces the same result with the same input arguments every time, and register a result data set in a DVC, or simply put it into S3 and assign some MD5 hash from this data set. And this is by itself, by this best practice, you have a version data set out of the box. So the data set, what is a data set for machine learning? It's affinity and an immutable data set. It should be versioned and could be downloaded locally if you registered in DVC. In this case, we recommend to produce a cloud first data set, so you do not mutate them locally. You just downloaded them locally and iterate locally if you need this. I'm a big advocate for cloud only experiments, but some teams and some companies really kind of love working in a local machines for some local debugging, etc. So it might be a nice to have feature. Then a machine learning featurization. Once you have a data set, you need to transform it into the features by normalization, vectorization, image resizing, or some machine learning framework specific things. And the result of the featurization step, is also data to be stored in a feature store and with a bunch of metadata gathered along that pipeline. So the DynamoDB and the way you can visualize and embed it into the user experience, into machine learning engineer experience, it really matters in this case. So the feature store is something where machine learning training job starts. So all those preparations are done just in order to amplify and accelerate machine learning adoption from the point where your features are ready. And all the Ubers of the world probably kind of seen those but the keynotes and presentations. They adopt the idea of one universal unified feature store that everybody starts with. And this is the point where the machine learning adoption is really accelerated across the company. So this is the point where you can identify yourself as a Netflix of the world, I would say. A summary for data layer. So adding machine learning awareness into data lake by enriching it with machine learning specific metadata can help you to transition from the classical data lake data analytical type of workloads into the machine learning workloads. We recommend investing into reusable sampling and featurization and other steps of the pipeline. So everybody in the team can use this. At this point, you can build it yourself using AWS tools like EMR, Athena, DynamDB, and Glue Catalog, with assistance of the companies like Provectus. And the feature store is the cornerstone. The feature store is a cornerstone that will amplify the adoption of the machine learning in your company. So moving on, so those are fundamentals. Let's talk about the SageMaker ecosystem that sits on top of the data you've been prepared so far. Before we jump into SageMaker details, let me run the second poll, also just to understand better the audience. What is the level of the SageMaker adoption in your company? So please press 1 if you don't have ML workloads yet. Please press 2 if you are not using it at all because you're somewhere in other clouds or on-prem. Please vote for 3 if you're also not using SageMaker but running machine learning workloads on EC2 or kind of commodity AWS services. You choose 4 if you are using the SageMaker fundamentals like notebooks, training, and hosting capabilities. And choose 5 if you are really an expert and you're using all the features and using a preview, beta features and preview, which are in preview mode now. All right. Thanks for your answers. I see most of the audience are not using the SageMaker because it's on their on-prem or in other clouds. A good feedback, so it's interesting. Thank you so much. Let me close the poll and share results for you to participate. So reminding experimentation flow, it starts with data pre-processing through model training and model evaluation. And the easiest way for me to explain what is a SageMaker experiments is the analogy and with a tensor board, which I'm sure all of you are pretty much aware of, and I believe you're experts in using a TensorFlow and TensorBoard as machine learning engineers. So those are the features that we all really like and use all the time. However, like TensorBoard has some flaws. It tracks the training step logs only, and as we saw, the experiment is much more than just a machine learning training job. Also, the TensorFlow doesn't track run parameters, and comparing runs is not as straightforward as it could be. It has a TensorFlow and PyTorch support only, which is not bad, but anyway, need to mention. You should do it yourself on AWS. It's not a rocket science to spin up a Docker container with the TensorBoard. However, some heavy lifting on syncing data from S3 and making sure it's visual, kind of the pipes work correctly is something you have to deal with. The SageMaker team went further and used that. I believe they were inspired by many tools like ML Flow, TensorBoard, and other tools in the ecosystem, and they built a SageMaker experiment that offer a seamless integration into the existing machine learning workflow. And it offers a structured organization scheme to help users group and organize their machine learning iterations. So it provides tracking and analytics of the experiments. And as a side effect that I really personally like as a software engineer, it facilitates a decomposition of monolithic spaghetti-like Jupyter notebook-based workflow into a multiple reusable steps. So what we can track with the SageMaker experiments: the parameters of the run, the inputs and outputs of each step, the artifacts that are being produced by each step, and the metrics that are being exposed from each step. And so you can the goal of the experiment is to choose the best model out of the many trials that in the terminology of the SageMaker experiments. So for you can visualize this the experiment results in a SageMaker Studio. The SageMaker Studio, I don't have a special dedicated slides for the SageMaker Studio, but hopefully you've seen the reinvent keynotes and like the landing pages. So it's just a Jupyter notebook extension, an umbrella on top of IDE, an umbrella on top of all the new services that AWS introduces. The good thing that I really like about this architecture, it's a super open architecture. The data that is being produced during experiments is saved into S3, and it's also available through API, so you can build your own analytics on top of your own experiments. So it doesn't lock you into any SaaS third-party service. You can fetch it as a data frame, and you can build like your own plots, your own analytics on top of that. So this is actually the feature that is actually essential for all of this, all of the SageMaker and AWS services. TLDR, the pros full of the SageMaker experiments. Fully managed, ability to track rich set of parameters, ability to build a complex plots in Studio, and ability to extract all the information for custom analytics, and obviously native integration with the rest of the AWS services. You can push to SageMaker endpoints right as a last step of the SageMaker experiment. The current limitations, they're not actually limitations, but just things to be aware of. Some of the things are here by design. So it doesn't allow to build a complex DAGs. Right now, there is just a sequential execution of the steps. There is some like lack of instruments for configuring robust pipelines, like retries, timeouts, etc. Not a limitation, but just a thing to be aware of. It's available in SageMaker Studio only. So if you're not using a SageMaker Studio, you don't have this this capability available. So again, it's being updated and released every single week. Probably by the time by the time we will finish this presentation, those limitations will be gone. So moving further, the as we mentioned, there is some sweet spot for SageMaker experiments, but there is another sweet spot for lower level orchestration service of choice, which is Kubeflow, that goes beyond the SageMaker ecosystem and could orchestrate the machine learning pipeline that starts with this data sampling, the machine learning training through the validation, evaluation, and production deploy. So the quick overview of the Kubeflow that we recommend layering on top of SageMaker, and this is an example of very simple pipeline, very simple machine learning model, basically experiment that has been trained with Kubeflow pipelines. It's a very basic just churn prediction model, but you see how complex this DAG might be if you implement it in a very modular and reusable way. So it's clear that sequential steps that are being being provided by SageMaker experiments in this case is not enough. So the best practices of using Kubeflow on AWS. Again, invest into library of reusable steps. It's kind of the best software engineering practice here that is being facilitated. So use a SageMaker operators for Kubernetes. If you've heard the recent releases from Kubernetes, you can like basically there is a operators, so you can launch a SageMaker jobs directly. So you can keep the orchestration layer very thin and still benefit from using managed services, fully managed training jobs on SageMaker. Obviously, use EKS. It will save like tons of time of managing a Kubernetes cluster. Use a separate on-demand and spot node groups for CPU and GPU bound machine learning tasks. The good best practice I like a lot of using FSX for Lustre it's an open source file system, a protocol for it's a high throughput. You can think about it as a high throughput, a kind of gateway from your EC2 instances to S3. That will allow you to work with a massive data right from the S3 and not transfer data back and forth to your physical nodes. Some challenges still under rapid development, breaking changes all the time. It still needs an ops support even on EKS. So if you don't feel comfortable managing a Kubernetes cluster, don't go this route. So still like resource management between service and machine learning workloads might be challenging and will require a dedicated heavy lifting. Poor support from AWS community, like Kubeflow, it's like a GCP first project. However, it's a good chance to start contributing. So as in Provectus, we're contributing a lot into this. So in summary, it's the Kubeflow. It extends the orchestration beyond SageMaker ecosystem. It's built on top of Argo workflow. If you're familiar with this, you should be excited about the GitOps way of doing things now. So if you're really kind of from that group, go for it. Build a complex DAGs, purposely build UI for machine learning and growing open source community. However, as I mentioned, requires deep Kubernetes and ops expertise to manage this. So fastly moving to another exciting service that I wanted to cover today is a SageMaker Debugger. How do we debug the models? The models are actually the code, and the same software engineering best practices as unit testing, logging, and peer review are quite applicable for this. but there is some machine learning specific way that how we debug our models. Basically, we experiment and we track loss curves and we check the model outputs. So the old and the very basic way is just to watch logs and watch the loss, the model loss scalar while it's trained. That's good, but it takes time and it's quite painful. Then, as a next step, you can choose to install a tensor board. Again, tensor board. I don't have. Don't get me wrong. The tensor board is a great tool. It's just the way for me to explain you what SageMaker Debugger is. So the curves are good, but still, can we go beyond that? The SageMaker Debugger is a logging and statistics and alerts for machine learning training process. How it works: during the training, it writes all the logs into S3 bucket. It reads it and analyzes with the special rules that I will cover later, and it sends the alerts into Amazon CloudWatch, and you can analyze those alerts and analyze the training process using a SageMaker notebook and the SageMaker Studio visualization. That's a great service that can save you tons of time while training and debugging your machine learning models. This is the list of out of the box rules, which is growing every day. So you can use it for vanishing gradients, overfitting, poor weight initialization, and saturated activations, and many others. So you can also write your custom rule to stop your experiment, to stop your training early and don't waste your time. So summary, pros. It's flowing through the graph. I really like this term and this analogy. So it goes beyond watching scalars during the training and provides a full visibility into history of all tensors. That's an essential what the debugger is being built for. Early stopping and near real-time alerts. Also operationalizing it. So the training is already a production workload that needs to be operationalized with alerts and monitoring and this type of instrumentation. Pretty easy to start. Minimal code changes to start logging into SageMaker Debugger, and yeah, growing set of out-of-the-box rules. Few very minor limitations that we see now. So currently it produces errors only. You cannot mark the rules for warning. So you always stop your training when something when some rule goes south. Well, I believe that's going to be kind of in a roadmap, but as we speak, it doesn't exist. And SageMaker built-in algorithms don't have this feature, so it's still a little bit of black box. So when you train a built-in algorithms, you don't quite understand how the training goes, and this is something that needs to be probably elaborated with AWS team as a feedback. So they always listen to the feedback. So I believe jointly we can make it better. The last AWS service, SageMaker Model Monitor. Very quickly, once you go to production, the data in production is different from the data that you've been using for the training. And the SageMaker Model Monitor, it monitors production data quality and alerts when issues appear. It's a one-statement description of what a model monitor is. The idea is that the training data should be statistically the same as production data. And how it works under the hood. So you have your SageMaker endpoint, which accepts requests and returns the predictions. And you specify the training data that has been used to train your machine learning model. The SageMaker model monitor mirrors the traffic from your model into a separate S3 storage. Then it uses calculates baseline statistics out of your training data, and uses the scheduled monitoring job to compare the baseline statistics with the statistics gathered from the production. And it also reports all the violations into CloudWatch. So this is as simple as it is. However, and the question is, what is what is really a SageMaker model monitor? Except what is the science part of the SageMaker machine learning monitor? The science part is actually a very straightforward but very useful library, Deku, which is built on Apache with Apache Spark, and that represents that monitoring job. What Deku does, it calculates the basic statistics, mean, max, average, standard deviations, etc., and also runs a two-sample Kolmogorov-Smirnov test for comparing two data sets, and missing columns, and few other statistics that it gathers. The challenge here is that the data with the same statistics, mean, max, and the standard deviations, can represent a completely different data sets, as you see in this image. So you should go beyond this just gathering as the simple statistics, because yeah, it may not provide the full visibility into your production data. So the beauty of the SageMaker model monitor architecture, again, as many other AWS services, it has a pretty open architecture. So instead of this Deku library, you can run anything that you want in this container and build your model-specific rules and analytics to watch for violations and to watch for concept drifts. So what we've built for ourselves, and we also offer to our customers, it's a value-add model monitoring features that in this anything you want package. So it adds real-time processing and alerts. By default, the SageMaker job is a scheduler job. It's not quite real time. By default, SageMaker model monitor monitors just a tabular data. We can monitor image data and text data, and we can apply advanced anomaly detection techniques to identify anomalies in your production data. That's kind of a value add that we offer, and that you can build it yourself, purposely built for specifically for your machine learning models. So the SageMaker monitor summary, it's a built-in container with schema extractor for training data. And it's a built-in container for mean, max, and KS stats. But the main value of the SageMaker model monitor is in all this heavy lifting and all this kind of under the hood stuff that fully provides a fully managed data wrangling, traffic shadowing, job scheduling, pushing metrics to CloudWatch, and retrieving latest job results. So the integration with the rest is the key element, that the key value that I see in a SageMaker monitor. So the I'm gonna finish with the deep dive, and here is a time for the offering that we're gonna put in place, and I'm gonna give a word to Preetpal.
Hello, thank you, Stepan. It was awesome, and thank you, Chris, for an awesome session. Yes, you know, as part of the offering of ML infrastructure acceleration, we're going to select 10 customers, and we're going to provide a fully funded engagement, which will require, dedicated time from us, and we are not seeking any money, because it's a fully funded engagement. And the format is one-day workshop. It's on-site if you are in San Francisco Bay Area, Seattle, Chicago, New York, or Dallas. Remote if you are in any other geo location. So it's a combination of working with you along with AWS experts and Provectus. So we'll work together to deliver an awesome value, fully funded in one day of workshop. And the key thing is there's a qualification process, and we want to see, go through that to see that if you qualify that. So what exactly the offering is, so based on your needs, like for example, if your need is you want to have a SageMaker adoption within your organization, productionalize, any kind of ML research that has been done, scaling ML use cases across the enterprise readiness for compliance. This is a big issue in many organizations from compliance perspective. A lot of things are developed, but compliance is coming heavy on data science side of the organization. And reproducibility, on scalable ML workflow. So with the offering that we are providing along with AWS, you'll get a SageMaker-based infrastructure, feature store data versioning, reproducible machine learning pipelines, auditable FDA SOC 2 compliant ML workflow, very important for many organizations these days, model versioning, and model monitoring. So that's what is the overall offering that we have on the Provectus side.
Thanks, Preetpal. So those are very brief ins and outs of this offering. I would the key dates here is March 25th for customer qualification calls, April 1st. Just screenshot this slide. So if you're interested and reach out to us, happy to chat and happy to to dedicate our time for you guys. I'm actually really happy to spend some time answering questions. A few questions there, and so before that, let me wrap up the slides, and I'll talk through the questions. So the webinar takeaways, again, the model machine learning infrastructure accelerates time to value for machine learning initiatives and increases the trust from the business to your machine learning and AI applications. And Amazon SageMaker has the broadest and deepest set of fully managed tools for building and managing applications at scale. So however, it's a broadest and deepest, but it's not a silver bullet. You have to look around into many other awesome AWS tools and services for data processing, storage, and metadata management to complement it and build the end-to-end infrastructure for your organization. And also don't be afraid to bring open source tools if you have expertise. So that's I would happy to take questions. Let me read few of them, probably like 2 or 3 questions. The first question is from John. How do you deal with data lineage? A good question. So actually, when you let me I have a separate 10 slides for the data lineage and how to do that, but I can try to answer very briefly. We can elaborate on this afterwards. So if you have every step of your data transformation pipeline versioned and codified if you produce enough metadata out of the each transformation step for the next stage. The lineage is the way to stick all these steps together and build use that metadata to analyze the lineage. So it's an issue of just one SQL query. So you can give me all the models that has been built from this data set. So you can sift through the entire pipeline, and so the key here, codify your pipeline and version your pipeline steps. Don't execute it ad hoc manually, and gather all the metadata along the way. That's a high level. Actual implementation needs deeper dive. We can probably cover this in a kind of other session. So the second question from Bradley: can you recommend a database store to serve as a feature store? Can you just use DynamoDB for this? Yeah, that's a good question. So you can start with just a simple. It depends on your use case, and it depends on the way you use machine learning model in production. If it's an offline use case, when you score the model as a batch job, so having it as a just a S3 storage, same Parquet or other type of storage, with some just metadata stored in DynamoDB, for instance, before we usually use DynamoDB for this. That's kind of the simplest way to go. Then you should look at the workload pattern. If you're using a machine learning model as part of your kind of real-time pipeline, or as a part of your streaming pipeline, so your features need to be hot and need to be a part of this part of this pipeline for the inference part. For the training part, it still could be, you can still could be S3 with some metadata could be more than enough to store your feature for offline training jobs. So it's basically a cache layer. So instead of transforming all the features all the time and forking your data pipeline from the very beginning and reinventing the wheel all the time, you keep investing into your pipeline, and and as a result, you will have this kind of cached features to be reused across many machine learning engineers, many machine learning projects. So we already like 55 minutes. We still have few questions not answered, but I believe I'm happy to answer. The questions are really good. Maybe we can take it offline, and we can set up another one-to-one sessions to go through those questions. Thank you so much for the very thoughtful questions. Pretty good traction, guys. Happy to see you, everybody here. Hopefully we will continue bringing the original content. We always try to add the original content into all the presentations, since we think that you can go and read the landing pages and try the basics yourself, but looking under the hood and complementing with some real world examples and experience is very useful for you guys. Yeah, I will stop here, and Preetpal, if you have some closing notes, and Chris, if you also have some closing notes, happy to give you a word.
I just want to say thank you to all for joining, taking an hour from your day. And I would highly recommend that you guys take advantage of the fully funded offering that we have. It will add a lot of value to your organization. And would like to thank you once again for joining. Thanks.
Hello, this is Chris again. I would just add, sort of to echo Pritpal's sentiment there, this is a tremendous value to get a one-day workshop setting with Provectus to understand some of your problems, get some questions answered, brainstorm solutions. I would encourage you to take full advantage of that because it is indeed a valuable and rare experience. And with that, I can give it back to Pritpal to shut us down.
Okay, thank you.
Yeah, thank you. Shutting down.
You guys have a fantastic rest of the day.
Yeah, who has a control?